Hi guys, today's lesson is on systems of inequalities word problems. So I'll do a couple with you and then you will do a couple on your own. So it kind of puts together everything we've done with linear inequalities. So just keep that in mind. Our first problem says, suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. So the first thing I would do is identify your two variables, essentially. What two things are you talking about? So in this problem, we're talking about flour and cornmeal. So I'm going to let X equal flour, and I'm going to let Y equal cornmeal. And we'll write equations about both of these with the other information given to us. So let's identify that next. It says that flour costs $1.50 per pound and cornmeal costs $2.50 per pound. And I want to spend less than $25 on flour and cornmeal. So that's something else given about the cost of these things. And then it also says I need at least 6 pounds altogether. So that's something else that's like talking about the weight as well. So we can make two equations. So again, I know that flour is $1.50 per pound. And I know that cornmeal costs $2.50 per pound. And it says that I want to spend less than $25. So that right there says what our inequality is going to be. So as long as I don't spend over $25, I'm good. So to show that, we would use less than or equal to 25. All right, so that's going to be kind of our starting point here. So I know I can buy, well, I don't know how much I can buy, but I know it costs $1.50 per pound of flour. So I'd write that $1.50 times X. Plus, I know it costs $2.50 per pound of cornmeal. And I don't know how much I can buy of that, but I do know when I buy both those things and combine their cost, I need to spend less than or equal to $25. So that's going to be one of our equations. Our other equation is going to talk about that we need at least 6 pounds altogether. So some amount of flour plus some amount of cornmeal has to be, and it says at least 6 pounds. So think, if it needs to be at least 6 pounds, does it need to be less than 6 or should it be greater than 6? So if you need at least 6 pounds, that means we need to be bigger than or equal to 6 pounds. So that's going to be our second equation. Now we'll graph both of those to find our solution. So let's go ahead and do this one first. We're going to solve this to get the y by itself. So I'd first have to subtract x from both sides. I would be left with y is greater than or equal to negative x plus 6. So I can go ahead and graph this. So I'm going to start at my y-intercept, which is that positive 6. So I'm going to count up 6. 1, 2, 3, 4, 5, 6. And my slope is this negative 1 over 1. So that means from that dot you just drew, go down 1 and right 1. Down 1 and right 1. And I'm going to do that for a while because I'm not very good at making straight lines. So the more dots, the better. Because this says greater than or equal to, that line underneath is a very key indicator that I need a solid line. Greater than means that I'm going to shade above that line. So on top of that line. All right, now we have to solve the other one to get the y by itself so we can graph it. So we have $1.50x plus $2.50y is less than or equal to 25. So my first step would be to subtract my $1.50x to the other side. Those will cancel, so we'll have $2.50 y is less than or equal to negative 150x plus 25. Then to get rid of this 250 in front of y, I divide everything by $2.50. So when I do that, I end up with y is less than or equal to, then negative 1.5 divided by 2.5. If you hit math, enter, enter, you should get negative 3/5 x. And then 25 divided by 250 is actually a positive 10. So this is our line we're going to graph. Start at your y-intercept, which is 10. So I'm going to go up to 10. Put my dot. My slope on this one is negative 3/5. So that's down 3 and right 5. So down 3, right 5. Down 3, right 5. All right. Then it's also less than or equal to. So again, that line is my indicator that this is going to be a solid line. And it's less than, so I'm going to shade below this line. So now where my yellow and my blue crossed each other, that entire region is the solution. So everything inside there is the solution. So now where it says write 2 possible solutions, you can literally pick anything. So remember, we said flour was the x, and we said cornmeal was y. So remember, y is the one that goes up and down. So pick anything. It really doesn't matter. Let's just say I pick 6 pounds of flour. That would mean my x coordinate is 6. So I have to go over 6. So 1, 2, 3, 4, 5, 6. I don't know, we could say up 2. That is a solution, 6, 2, because it's in that shaded region. So there's 6 pounds of flour and 2 pounds of cornmeal. Now we could pick something else. It really doesn't matter. I'm going to go all the way over to, and I'll pick this point right here. So that's what? Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up 1. So 12 pounds of flour and 1 pound of cornmeal is another solution. So there are many solutions. Those are just 2. So just pick any 2 coordinates in that shaded region that was like double overlapped. Okay. The next one says a seafood restaurant owner orders perch and salmon. Perch is $4 a pound and salmon is $3 a pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. So this is going to be very similar to the one I just did. So you know, first thing you're going to want to do is identify what your X and your Y are. What are your 2 unknowns? So establish that first. I would have said that X is perch and Y is salmon. Now that you have that, you're going to create your 2 equations. So one thing you know about is that perch is $4 a pound and salmon is $3 a pound, and that you cannot spend more than $240. That would be one equation. Talk about that relationship. Your next one is that he wants to buy at least 50 pounds of fish. So when he combines, buying perch and salmon, he wants to buy at least 50 pounds of fish. So go ahead and see if you could create those 2 inequalities. All right, on number 3, it says, the We Sell CDs website plans to purchase ads in a local newspaper to advertise their site. Their operating budget will allow them to spend at most $3,000 on this advertising adventure. An ad will cost $30 to appear on the weekly paper and $50 to appear on the weekend edition. They plan to run at least 20 ads. All right, so let's first identify our variables. We have a weekday paper to put an ad in, So I'll let that be X. So X is the weekday paper. And we'll let Y be the weekend edition of this paper. All right, so what I highlighted in red is they want to spend at most $3,000. And I know what I highlighted in blue next, it costs $30 to appear in the weekday paper and $50 to appear in the weekend. But I want to spend at most $3,000. So that means I want to spend less than or equal to $3,000. So my first equation would be that $30, right? My weekday was $30, my weekend was $50. So $30 times X plus $50 times the weekend ad paper needs to be less than or equal to $3,000. The other information is they plan to run at least 20 ads. So you need to think. If it says at least 20 ads, that means it wants more than 20, right? I want anything 20 or bigger of the amount of ads. So I don't care how many weekday or how many weekend, but when I total up my weekday and my weekend ads, I want to see at least 20 or more. So that would be your next equation. All right, so if we go ahead and solve those for Y so that we can graph them. So X plus Y is greater than or equal to 20. You'll first subtract that X and put it on the other side, and you will have that. So negative X plus 20. All right, let's also label right now. So the X-axis is weekday, and the Y-axis is the weekend paper. And since there's not 20 squares up to start our graph at here, since it wants us to start at 20, I'm going to count everything by tens. So we'll just say this is 10, 20, 30, 40, 50, and you could do anything, 60, 70, 80, 90. We'll just stop there at 100. All right, so it wants me to stop at 20. And then it wants me to go down 1 over 1. And this is going to be like very much approximated. So our line, we know will look something like that. It is greater than or equal to, so it is a solid line. And greater than means to shade above. So we'll be shading everything up here. All right, when I solve my next one, I have 30x plus 50y is less than or equal to 300. So I would first subtract this 30x and put it on the other side. So I have 50y is less than or equal to negative 30x plus 300. Then we have to divide everything by that 50, since that's like 50 times y. So negative 30 divided by 50 reduces to negative 3/5 x plus 300 divided by 50 is 60. Sorry, didn't mean to write 600. 60. 300 divided by 50 is 60. So we'll graph this, and we'll start at the 60. So we said 60 is here. And again, this is very much approximated. We have to go down 3 and right 5. Down 3 and right 5. So it'll be some line like this. All right, and we want to be less than that, so that's everything in here. So where my pink and my blue cross each other there, that is our solution. So you could literally pick anything in there. So if my one side went by tens, we'll also make this side go by tens. So let's just say I want to go right 20. So we'll say 20 weekday. Let me get to black so we can see it. So 20 weekday would go right here. I could say 20 weekday and 20 weekend. So 20 weekday and 20 week end. Those are in that solution area. I could say 50 weekday and 10 weekend. What I put is not the only answer. There's so many answers. Any coordinate in that space. So I said, let's go right to 50 and just up 1 to 10 weekend. And that would work. Anything in this area is a solution. So those were just the two that I picked. Go ahead and try number 4. It says, Mary knits scarves and sweaters to sell. Scarves take 2 hours to knit and sweaters take 10 hours. Mary would like to spend no more than 40 hours per week knitting and she wants to knit at least 5 items per week. So I would let X equal the scarves and Y equal the sweaters. So your x-axis is scarves and your y-axis is sweaters. So go ahead and try to create your 2 equations, then graph them, and then pick any 2 solutions within your double shaded region. Number 5 says, a clothing store has a going out of business sale. They're selling pants for $8.99 and shirts for $3.99. You can spend as much as $60 and would like to buy at least 2 pairs of pants. So our 2 variables here, we're talking about buying pants and we're talking about buying shirts. So I will let X be pants and Y be shirts. So my x-axis is pants and my y-axis is shirts. All right, so let's see here. I know that pants are $8.99 and shirts are $3.99, and I can spend as much as $60. So that means I can't spend over $60. So my inequality would be less than or equal to 60 because I can't spend more than $60. So I know that each pair of pants, which is X, is $8.99. So $8.99 times however many pants I'm going to buy plus $3.99 times however many shirts I'm going to buy needs to stay under $60. It needs to be less than or equal to 60. That's going to be one of my inequalities. It also says that I would like to buy at least 2 pairs of pants. So that's literally just about X, right? It says nothing about the shirts. I know that however many pants I want to buy needs to be at least 2 pairs. So that means I want to buy 2 pairs or more. So that would be greater than or equal to 2. So it doesn't always, like your equations do not always have to contain both variables. It's whatever they give you in the problem. So I can go ahead and graph X is greater than 2. So remember, think about this like as X equals 2. I would find 2 on the X-axis and draw a line straight up and down. Since it's greater than or equal to, my line will be solid. And since it's greater than, I'm going to shade to the right. So that's one of my equations graphed. For my other one, I am going to have to put it in slope-intercept form, which just means solve this baby for y. So your first step would be to subtract your $8.99 times x to the other side. That would cancel. So we'll have $3.99y is less than or equal to, I have a negative $8.99x and a positive 60. Then I'll go ahead and I'll divide everything by the $3.99 in order to get that y all by itself. When I do that, I end up with y is less than or equal to negative $8.99 divided by $3.99. Put that in a calculator. It should tell you it's negative 9/4, and then 60 divided by $3.99 is 15. So I now have this in slope-intercept form. So to graph it, I start at 15. see if I even have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All the way at the very tippy top. And then I'm going to go down 9 because it's negative and right 4 because it's positive. So from that dot, go down 9 and right 4. And if we could do it again, I would say do it, but we can't. It is less than or equal to, so we will connect our 2 dots with a solid line. And it's less than, which means I need to shade underneath this line. So I'm literally shading right here. So that area here is where all of your solutions lie. So now again, we can pick any point that is in that area. So let's just say I pick 3 pants and, I don't know, 2 shirts right there. There it is. So 3 pants and 2 shirts would work. Or I could say do 5 pants. So 1, 2, 3, 4, 5 and 1 shirt. That's also in there. So 5 pants and 1 shirt. Again, pick whatever makes you happy. It just has to be in that little region. All right, let's go ahead and have you guys try number 6. So I'll read it to you. It says, you like to see how many baseball and soccer games you can attend this spring. Travel time to baseball games is 2 hours and soccer games is 1 hour. You would like to spend no more than 15 hours traveling to the game. In total, you would like to attend at least 8 games. So I would say let X equal baseball games and let Y equal the soccer games, and then use that other information to make your 2 equations. Go ahead and put them up here in A. So the x-axis we'll call baseball, and the y-axis we'll call soccer.